Hi everyone. In today's video, we will see this as a continuation of the previous videos. We are going to take analog values and we are going to try an if condition, if else condition, and we are going to combine both because we already combined switching digital inputs with the if condition. Here we will try to combine analog values with if condition, or we can say basically we can create an analog based indicator system we are going to create, right? So first we will write the particular code to we will write an algorithm, right? So let's say we are going to take an analog values. So let's say if the analog value is okay, so let's say value, so I'll write it as a comment. So if the value is more than a particular value, like let's say more than 512, because we know analog values are from 0 to 1023 when it comes to analog input. So we will have the half, okay, we will take the half. So half means 512, so or 511. Okay, let's go for 512 for the moment. So if value is more than 512, okay, more than 512, we will switch on an LED, okay, else, so otherwise that means if this is false, so otherwise or else, all are same, right? So I will write otherwise. So this is the action one, so I will write like this so that it will be more clear. Okay, so this is what's happening here. Okay guys, LED on. Otherwise, that means if it is less than 512, right? Because more than 512 LED on, so otherwise means less than 512, less than or equal to 512. So less than or equal, right? This is common sense, right? So LED should go off. So this thing is the algorithm. So we are going to implement that. So for that, first what we have to do from what we learned from these analog input values. So first you have to mention, okay, we are going to use a particular value as particular analog input. So you know all those things. So let's not waste much time on this. So let's say pin number A0. If you don't understand, go watch my analog videos and come back. Okay, analog input videos and come back. So input, right, because A0 input. So you are going to connect an analog input value to A0. Maybe a variable resistor where you can rotate and change the value, or a temperature sensor, or anything you like. Okay, any analog input giving source you can use. So because I told about the variable resistors already, so you can use that. It's up to you. So also I'm going to use an LED, right? So I will mention an LED. So let's say I'm going to use LED pin number 13. So again another pin mode. So 13 output. So you know these things, right? So now we are using two things. You see in the first line, that means line number 4, we are using input, analog input, and line number 5 we are using digital output, okay, along with the if condition. Okay, so here I am going to read the analog value first, because we see this value is more than 512 LED on. So to get the value I have to read the analog values, right? Okay, so I will, what is the keyword for that? Analog read. So I will write analog read. You see this, okay, analog read. What is the pin number? A0. Okay, A0. And what I will do, I'll simply have a, so am I using 0? I'm using A0, I'm sorry. Okay, so then I have to assign it to a value, right? I have to assign it to a variable, right? I said you y. So since I am using the analog read only within the void loop, analog read values, because void inside the void setup we use A0, but we don't use the analog read total value. So that variable we are going to use only within the void loop. So if I define it inside the void loop, that is enough. But still, as a common practice, I will declare it as a global variable. Okay, so I will say int as usual x. Okay, so then what I will do, I will assign x to analog read A0. Still, if you don't understand anything, you have to go and watch my previous videos. There is the only way. Then you will understand what I am doing here. Very easy thing, because I have repeated it for so many times in the previous videos. All good. So I read the value. Now what I have to do, I have to implement this scenario or I have to implement this algorithm using if else conditions, because this is if condition, right? If this condition is true, I have to switch on that LED, otherwise that means else I have to switch off that LED. Understood? So I will write an if condition. So there, so what is the value? Value is x, right? Because analog value read value is x. If it is more than 512, I have to switch on the LED. So I will say x more than 512. So I will have a set of curly braces. So I will switch on that LED. So how to switch on that LED number 13? We have the keyword for that called digital write. You understand what I'm talking about? Digital write. So now we are beginning to combine the codes that we learned, okay, to create a full complete system. Digital write 13 what? Output. Sorry, not output, I'm sorry, I got confused. 13 high. Okay, that means 13 is on. That means 5 voltage is giving us an output in the pin number 13. Else means, so this line is finished now. The line number 1 is implemented in line number 11, from line number 11 to 13. Okay, so this is the implementation of line number 1. It is understandable. Then you will have the wife of the if condition. Who is the wife of the if condition? Else. Here if we have one wife, that is enough. Why? Because we have two choices, only more than 512, otherwise action 2. So if you use an if with the condition, and for otherwise if you use an else, that's enough. Okay, so one wife is enough. So otherwise what you have to do? What is the action plan for the line number 2? LED off. So the same LED you have to switch off. So how to switch off the LED? It is that simple. Digital write 13 low. I think this is very clear. Okay, so that's all actually. So the program will come. It will start from void setup. It will do whatever it wants. It will run it one time. So we will mention this is input, this is output, and all those things, and we will start the void loop. So we will jump to the first line. We will read the analog A0 value. We already said there is an input. So analog input, read the value and assign it to x, no matter what the value is. So once the x value is assigned, then we will check whether this x value is greater than 512 or not in line number 11. So in the if condition, right? So if this x value is greater than 512, let's say 600 is coming as x value, 600 is the x value. So 600 is greater than 512 is now true. So then the if condition becomes true. If that becomes true, then we will do this line, because this if condition is the area of these two curly braces. So this only line is lying within the two curly braces. So we will do that. And once the if condition is true, because the line number 1 is true, line number 2 obviously is false. So else condition is obviously false. So the system will skip the else condition. You remember, right? When it comes to if else if, something like that, if one condition is true, every other condition will be skipped. Only if the one condition is false, then only the second condition will be checked. So you know those things. So we will skip the else and we will come to the last line, and we will come here again. So let's say you change analog read values. Now you are rotating that preset, or you are changing the value of the LDR, the resistance value of the LDR. You are putting light on the LDR or decreasing the light, or you are doing some changes, right? Or your sensor is changing the value, so giving the low value in the next iteration. So let's say this time x is 400. So 400 is greater than 512 is false, right? It is not true. So the if condition is now false. So whatever the area of the if condition will be immediately skipped. Since the if condition is skipped, then else condition, there is no else if, there is only else. So since the first one is false, the second one will be true, because you know, if the value is more than 512 if it is false, then what is the meaning of that? The second one is true. That means value is less than 512. So otherwise is true. So otherwise is else. So the otherwise will be now implemented. Else is true. So the line number 15 will be immediately implemented, and the else loop will finish here. And will come to the next line, and again will come to the first line of the void loop to check again what is analog value, and to again implement the if else condition. Okay, this is fine. So let's say let's say you are going to have 3 conditions. So you are going to say, okay, if the value is more than 750, okay, more than 750, LED 1 on. Okay, then if the value is somewhere between 500 to 750, LED 1 off, one should go off, and LED 2 should be on. 2 should be on. Okay, So if the value is other less than 500, okay, less than or equal to 500, okay, so I will say less than or okay, let's add this less than or equal 500. Okay, so then it has to be, what am I missing out? Okay, oh god, it has to be LED 1 and 2 off and LED 3 should be on. Okay, so LED 1 2 off 3 on. So it's a bit complex, not complex, it's a little big work, but there's something missing. You see, in the third line we tell everything perfectly. LED 1 is on, LED 2 and LED 1 and 2 off, 3 is on. But in the second line we are not talking about LED 3. So there also we have to mention it. That is what we call validation, because in the first iteration if 3 is on, in the second iteration we want only number 2 should be on, right? I mean in the second line. So then 3 also will be on. Let's say it will be iterating again and again, right? Void loop. So in case at the first iteration maybe the number is less than 500, so 3 is on, other 2 are off. But in the next iteration when the void loop is running again, the number is between 500 to 750. So for in that case I want to switch on LED 2, not 3. 3 should be off, but we didn't switch off it here in this line, you see. So the previous time the 3 was on, now again this 3 is going to be on here. We don't switch off anywhere, so it will stay in the previous state, but meanwhile I am switching on number 2. So what will happen? Number 2 and 3 will be on, so that is wrong. So for more than 750 I should be switching on LED 1. For this 500 to 750 I should be switching on LED 2, and for less than 500 I should be switching on LED 3. Meanwhile other LED should be off. So that thing as a validation we have to add. So what I will do is here I will add 3 off. So we should make sure it happens. Okay, so also in here if we are more than 750 we will simply write 1 on, the rest are off. So we are switching off the rest because we don't know the previous state of the rest of the LEDs. If they are on, then everything will be on, then that is a disaster, right? So 3 also off. So you understand now, everything is clear. So you are in, when it comes to program, you have to say every state which is the state of every variable in the if condition or else part. So then only things will be validated. So no big deal, you know these things are same as you are reading the analog values. So you write an if condition, you are saying more than 750. You are going to say there's an issue, so we have to use 3 LEDs, so we'll have used 10. Okay, so similar thing already we did in one of the previous videos, I remember. So it can be a repetitive to you, so that's okay, you can learn something or you can have some practice. Okay, so 10 11 12, let's say 10 is LED 1, 11 is LED 2, 12 is LED 3. You can name the LEDs. I don't want to do that because the video is already lengthy. So you can remember LED 10 is LED 1, 11 is LED 2, 12 is LED 3. If you want, you can name them also here next to the int LED 1 is equal to 10, like that. Okay, it's up to you. You know how to do that, right? So we will come here and we will read this A0 value. It's fine. So now we have to implement the line number 1. So LED 1 should be on, 2 and 3 should be off. That means pin number 10 should be high, 11 and 12 should be low. Understandable, right? So more than 750. So 10 should be high. Then I will write okay, 11, 11 and 12 would be high. Understandable? Understood, right? Sorry, this should be low. 11 and 12 should be low. That means LED 2 and 3 are low. Low, low. Okay. So here also the same scenario. But thing is, we should have check the second condition as well. Okay. So we have to write another else if, because we have 3 conditions. So here I will write an else if. Now we have already filtered the values more than 750. So when we come to the else if condition, we will have the values only less than or equal to 750. We know that, right? So if you check that the particular value is more than 500, then that is enough, because already the values are less than 750, right? So we will write another bracket, and we will write x is greater than 500. So that means x is somewhere between 500 to 750. So that is why I didn't have I didn't write it like x is between 500 to 750. I didn't write like this. I'll tell this. So I didn't write like this because I didn't write like this. We can write like this, but this is, there's no need, because whenever you come to the line, the values are less than 750, less than or equal to 750, because in the first, if we have already taken all the values that are greater than 750, we have to, if the value is greater than 750, we have already taken that in the first condition. So since we come to this line, that means the value is obviously less than or equal to 750. So this part is not needed. So if you check whether x is greater than 500, that is enough for us. So that is understandable. So what is the second condition? We have to switch on the second LED. So first LED 10 will be off. We have to make sure it goes off, because in the previous iteration, because the void loop is keep running, right? Every time we read the value and check, and we implement the else if condition. So in the first time, if the 10 is high, second time this second else is the x value are changed. So if we have to come into this loop, so still the 10 is high, but we have to switch off it here, right? And make only the 11 is high. So that is what I am actually doing. So I am copying this again, otherwise we will waste a lot of time. Oh my god, what is this asking? Damn it. Okay, come here guys, come here. It's asking something else. Okay, let's copy this and add this, paste. So 11 is high, so that is LED number 2. So basically what we are doing is, we have a LED indicator system depending on your input values. So you can have a green value LED for this red LED for this pin number 10, because the value is high, so you can alert. Medium value you can have a yellow LED, and what do you call lowest value you can have a green LED. So that means there's no risk. So only second LED is high. You can see in the line number 21, 10 and 12 are low. Okay, we made other LEDs low, because we don't know what is the initial condition of those LEDs from the previous iteration, right? Because this void loop is going to iterate forever. So that is why we make other LEDs low, so that it can be validated. So now you know x is greater than 750, x is greater than 500. So if we pass all these, if we miss all these parts, so what is the other values? Those are less than or equal to 500. Okay, so if you write an else condition, else, so if let's say the program is coming to else, that means all these two conditions are skipped. That means the value is not more than 750, not more than 500. Okay, that means it's not more than 750, it's not somewhere between 500 to 750. So it is obviously less than or equal to 500. Okay, if it comes to the else loop. So that is the third condition. Okay, so that means less than or equal to 500. So you don't need to write the condition, because the value, if it comes to else condition, obviously the value is less than or equal to 500. Otherwise it might have gone into the one of the two above loops, right? Above if condition. So here you have to switch on 3 and switch off 1 and 2. So the same thing happens. So I will copy this. Let's see whether it can be copied. Copy, and I will paste, and I will switch on only the third LED, right? So I will make this low, and I will make only 12 high. So now you can I will not explain this go through, so because we already saw this in the some digital based stuff. So same thing. So I can keep you open, so you can compare it with the algorithm. So you have done the same thing here, right? So for the value more than 750, you have done it in the if condition. Value between 500 to 750, you are done in the else if condition. Value less than or equal to 500, you are done in the last else condition. And you should understand why we make other LEDs low. Okay, because the void loop is keep running for infinity times. So you know why we have to make other LED so low, because anytime any loop can be implemented. So when it comes to the next time, if it is going to the other loop, so if we are going to switch on the other LED, so for that we have to make sure this LED should go off. So that is why if we are making one LED on, we are switching off the other LEDs off in the particular loop, because our task is, if the value is more than 750, that the first LED should be on, other should be off. Otherwise in the second case, second LED should be on, other should be off. In the third case, third LED should be on, other should be off. So you have to write that validation. so that you can guarantee this code will work. Otherwise we don't know. So I am scrolling up, I'm keeping that code so that you can have a look and try to understand what actually happened. So I'm not going to explain the code flow, you know that, because we are saying this if else conditions this with this so many times. Okay, so that's all. Go through the code, try it by yourself. If you have any questions, please feel free to ask in the comments. When I get the times, I will reply them. So I will catch you up in the next video. Until then, have a great day ahead. Bye.